Welcome. In this project, we built a real-time IoT graphics deep learning traffic analysis system using Amazon's GPU instances. As a research topic, we studied the scalability, latency reduction, and improvability of such systems. Our first research topic is compatibility. As a public PaaS, platform as a service, multiple users can add distinct CCTV stream URLs in the common platform. To reach this goal, we trained a single model using custom footages of many locations at various times of the day, morning, afternoon, evening, and night, and weather conditions, sunny, cloudy, hazy, and rainy, as long as the cameras are in a nadir as long as bird's eye view position. The same deep learning model can be reused. Such cameras can be installed on the walls of nearby buildings, attached to drones, or installed inside smart lampposts in smart cities. Also, we included various adapter libraries like OpenCV and FFmpeg inside our Docker image. There are totally 9 custom classes of vehicles, such as ambulances, shuttle buses, and trucks. To address the duplicate count issue, we use multiple object tracking, MOT deep learning instead of object detection. The greatest advantage of MOT over object detection is its resilience to both partial and total occlusion of vehicles.
Besides the CCTV camera from the HKSL government, we also support the video source from YouTube. Very simple, you just copy the link and paste it on the input box and give it the camera ID, and then click the green button. The GPU instance will be created in the back end immediately. This is the demo effect of the video source from the YouTube.
At the top of the screen is the results visualization. Each vehicle is labeled by immutable vehicle ID, and one of the 9 categories, and a fraction indicating how confident the machine is with that prediction. At the bottom of the screen is a table of vehicle counts.
This is other cameras. This is another cameras.
By the way, we have an interesting finding. When we initialize the first instance, the GPU is 38 degrees. After a minute of tracking, it's 53 degrees. What's interesting is, if you start a second instance without doing anything, the GPU is outright hot, 51 degrees. It means that the instances probably originated from virtualizations of the same machine. Our second research topic is improvability. The initial model required us to annotate thousands of video frames and trained for 157 epochs, which is not very sustainable. So we included a feedback function in case the deep learning tracking is incorrect, inspired by mechanic Turk. Users' feedback will be automatically converted into training samples for improving the AI system. The screenshots, bounding boxes, and categories are stored temporarily in a database. The fine-tune training can take place routinely, and such, the system can be refined automatically. Its crowdsourcing ability is an advantage of the PaaS platform as a service cloud service paradigm.
The manual instance creation and configuration from the AWS web pages are replaced by Cloud. The automation is accomplished by the bottle-free library and the Paramiko libraries. For latency reduction, the fetching Docker container is in the ECR, Elastic Container Registry, and using the instance of larger size can reduce the setup latency. And we push the Docker container containing the essential library and models to the Amazon ECR for GPU instance to download. The ECR repository should be same region as the EC2 GPU instance to reduce latency. This is the setup time for the GPU instance size, G40 and X large. As you can see that if you're using the larger instance and the setup latency will be decreased. This is the end of the demo part.
Thanks for watching.